Hello and welcome. So in this video, we're going to continue to talk about functions, and this is part 2 of the tutorial. If you're new to this channel, you may consider subscribing and hit the bell icon so that you continue to receive the updates. Let's get started. At times while working with functions, you may not be sure of how many inputs you want to give. For example, let's say you want the user to give any number of digits and you want to do a sum of those digits. So we are defining a general function called add numbers, where we are allowing it to accept variable length of positional arguments through this asterisk and args keyword. We are saying there's a variable called results, which is right now 0. For each number in the args, because this args would be a collection of numbers that will be passing. So for each number given as the argument, we are adding that number to results. This results plus equals num can be written as this. This is the same as results is equal to result plus num. So it to begin with was 0. Then you get the first number, you'll add it. Then you get the second number, you keep on updating it. And finally, you return the result. And this is the function call. And we are storing this outcome in a variable called sumResult, and we are printing it. So the function itself is not printing it. The function itself is returning it. We are storing that outcome in a variable called sumResult, and we are printing it. Let's see what happens. So it says 23. See, we have given certain numbers here, 0, 2, 8, 4, 9. Why did I say it's a variable length thing? Let's say I change this. I put some more numbers. Let's say I add 13 and 20 to this. So you can expect an addition of 13 and 20 to this number now because we've changed the length of arguments. Let's run this again. So see, the number is now 56. 23 plus 33, which is 56. This is the advantage of using this asterisk args. It allows us to pass the arguments of varying length. We can also pass variable length keyword arguments. What is the difference between them? First of all, to be able to do that, we'll have to put 2 asterisks and we'll have to write KWArgs, keyword arguments. Let me explain what it does. So let's say we define a function called print info where we want to display some general info about a person, and we are allowing the function to take variable length keyword arguments. So this keyword arguments would take the inputs in the form of a dictionary. If we refer to this keywords arguments.items, it actually is a dictionary, which will return the name of the input as the key, and that's called a parameter, and the value as the value of the dictionary. So dictionaries, if you know, is a key value kind of an inbuilt data structure. So whatever inputs we give here, let's say we give an input here, which is name. So name becomes a key, and the specific input we are giving, which is Alex, this input or argument is going to become the value. To simplify once again, the name of the parameter is the key and the value that we are passing is the value, and we are displaying that only. Let me run this. Let's say we want to display information related to name, age, and city, where this person comes from. It displays that key : value. Now, why did we say it's a variable length thing? Because if we don't give all these inputs, we only give inputs like name and age, would it still work? The answer is yes. If we just give one input, which is only the name, or any of these, just one input, would this still work? It works. If we don't give any input, would this work, or would this give an error? Let's try. Well, it still works. It doesn't display anything because we didn't give any input, but it doesn't give an error because it understands that we want to keep it a variable length argument. We talked about returning values, and so far we've been returning just one value. Can we return more than one value out of a function? Let's see. If we want to return the sum and difference both for 2 numbers, can we do that? So we're defining a function called sum and difference, which takes 2 inputs, A and B. And while returning, we're writing return A plus B and A minus B, which represents the sum and difference respectively. So this is the function definition, and this is a function call. We're giving it 2 arguments. A is 12 and B is 2. Let's run this. It displays a tuple, this kind of data structure where you have values inside the parentheses separated by commas is called a tuple. It returns a tuple. But let's say if we wanted to only obtain the sum or only the difference, how can we get that? Right now, it's returning something that you may not be able to straight away use or report. If somebody is asking a to-the-point question, what is the sum of 2 numbers? We should be able to answer that. We should not be just returning both the values. So this is called tuple unpacking. What we can do is we can take the same function, exactly the same thing that's written here, the call here, and we can do unpacking of this. We know it is going to return 2 values. So we are saying first would be sum and second would be difference. Make sure you give the right order because while returning, you first got the sum and then got the difference. So in the same order, we are writing sum and difference. Now, if you want to access the outcomes, you can easily do that because now sum is a variable which stores the sum of these two numbers, which is 14, and difference is a variable which stores the difference of these two variables, which is going to be 10. So let me just run this and you can see the message. Sum of the given numbers is sum and difference of the given numbers is this. Can we call a function inside another function? Let's have a look at a quick example of that. We're defining a simple function, which is add list numbers, which takes a list as an input and does a summation of all the values passed under the list. So it has a variable called sum, which starts with 0. And then we are saying for I in numbers, this would be a list. So we'll go over each element of the list and we are doing sum is equal to sum plus I. We are adding all the numbers and returning sum. Now there's another function which does a lot of work for us. So this is a general function called calculate, which returns a number of outputs, like it does a count, it does an average of all the values, it finds the maximum of all the values in a list, and it finds the minimum of all the values in a list. So if you see length, maximum, and minimum, these are inbuilt Python functions. We did not define them. We just have them identified. We also have a user-defined function, which is the function that we just defined above, and we are calling that. So we are looking at a mix of functions which are inbuilt as well as user-defined, and we are calculating the average. Average is what? The sum total divided by the count. Now, we of course have a function for average also, but just wanted to show you how we can bring a user-defined function here. That's what we're doing here. And what we are returning is, just like the previous example where we had only returned the sum and difference, we are returning the count, the average, the maximum and minimum value. And then this is a list that will be the specific input or argument that will be given to these functions, both the functions, the user-defined function 1 here and the other user-defined function, which is calling an already existing function inside. Once again, when we use calculate, it's going to return all these values. So we are doing an unpacking. We know in this order we are getting the options return. We know that in this order it is going to return these calculations. So it's going to give the counts first, then the average, then the maximum, and then the minimum. And we can then display all of these in that order. Let me run this. And here you go. You have the count, you have the average, you have the maximum and minimum. There were 5 elements that we had. You add all these elements and divide by 5, you'll get 30.2. And if you look at the maximum value, it's 50. If you look at the minimum value, it's 10. It's getting it right. Now, at times inside the function, you'll see different statements like pass and continue and break. Let's understand what do they do. So pass is essentially used if, let's say, you're working on a code and you're not very sure of a specific function. You don't necessarily define the whole function, but you don't want your code, which has multiple other functions, to stop at a point just because of that. So it says function definitions cannot be empty. If you're not sure of the definition, you're going to write that later, or somebody in your team, you're working as a team and someone else is supposed to work on this specific function, you can just choose to put statement pass here, and at least your code will not terminate with an error there. So just like it says pass means you're not getting into it right now. What about continue and break? Let's understand the difference. So we use continue statement to skip to the next iteration. Continue allows us to go to the next iteration, and break essentially terminates the loop when it is encountered. So let's look at it with the help of an example. Let's say we're defining a function which is called process numbers. We're trying to do some kind of a processing on numbers where we have a list of numbers and we have a target number that we are looking for in that list. To begin with, we have set a flag which is false. So this is a variable which we are setting as false, which is like the found status. Did we find the target or not? We are saying, no, we've not found it yet. When we find it, we'll put it to true. Then we are running a loop. We are saying for each number in numbers, if number is less than 0. So this is a list of numbers that we're going to give as an input. If the number that we encounter in the list is less than 0, we show a message, found invalid entry. Let's say negative numbers were not allowed. But you don't want to end it here. You want to continue to the next step because your task is not to just say that you found an invalid entry, but to reach to the target number. So what you're doing is you encountered a negative number, you print a message and you move on. Now, if the number is not less than 0, we come to the elif condition. We check if the number is equal to target. So these double equal to signs in Python mean equality. A single equal to is assignment. If you found the target, you will say that found the target, this is the number, and you make the flag true. That's it. And you break it because your task was ultimately to find whether a list contains a given number or not. But let's say the number was not less than 0 and you also didn't find the target. Then what are you going to do? You're going to just display. It may be a fair entry. It may be a number which is 0 or greater, but this is a number which is not the target. So we'll display that message. Once this piece is executed, possibilities are you would have come across a negative number, or you would have come across a number which is the number you were looking for, or you might have come across a scenario where you found a number which was not the target, but was also not an invalid entry. Finally, we are saying if not found. So let's understand what is found right now. So if this block, elif block, does not get executed, because this is the only block which is talking about a change to found. So if elif block does not get executed, found will remain false, which means you have not found the number. So you're saying if not found, and that not false would become true. Negative of a negative, not false, is true. So if this is true, then it displays a message, target number was not found in the list, which means I did not find it. However, if this has become true, that is, you found the target, this not found would become not true. And not true is equal to false. And if the condition with if is false, it will not display the message. So this is an additional if condition that we have put here just to display the final message. If at all the number is not found, you should also display that you finished going over the list, but you did not find the target. And if you found it, you would have mentioned it here itself that found the target and terminated. So it might take a little bit of time to understand, but if you get the logic, we can bring a lot of complex logics and put it in the form of a function to make our lives easier. Let's say we pass a list here, which is 12 minus 5, 24, 100, 7, minus 3, and 30. These are the numbers. And we are looking for a specific number called 29. Notice this number 29 is not present in the list. What we would want is that we go over each element, we display appropriate message, and finally display that we did not find the number. This is the list. This is a target number that we're looking for. These two are the inputs, numbers, list, and the target. And we are calling the function here, which will take these two inputs. Let's run this. What does it say? For the first number, 12, it says a pair entry. It's not negative, but it is not the target. Second number is negative. It says it's an invalid entry. Third number is positive. It says pair entry, but not the target. 107 fall in the same category. Negative 3, again, an invalid entry. 30 again says pair entry, but didn't find the target. And finally, it says the target number 29 was not found in the list. So it has gone through the entire list and displays the right message. Let's say if we change this to 100, then what should happen? The moment it reaches 100, it'll terminate because we have put a break statement here. Let's run this. So it says 12 was a pair entry, but not the target. Negative 5 was an invalid entry. 24 was a pair entry, but not the target, and found the target number, and that's it. So it's a decent communication looking at the right logic. Now let's talk about the scope of the variables with respect to the function. So there is something called as a local scope, which refers to the variables which have been defined inside the function. You cannot call them outside. And then there is a global scope, which refers to the variables which have been defined outside. Just to keep the concept very clear, we have named the variables such. Global variable, this is a variable we have defined outside the function. We're defining a simple function called scope check, which has a local variable. We are assigning it a value 5. Inside the function, we are doing a print of the global variable and local variable. This should not have a problem. And then we are calling this function called scope check. So a function can access the global variable. A function can access the local variable. The difference is that a global variable can even be called from outside the function. So I don't need a function to strictly call this global variable. I can straight away print it. Let me run this. What should be the output? It should display the output as per this scope check first, which will display 10 for the global variable, 5 for the local variable, and once again the global variable was called, so it displays 10. But let's say if I try to call the local variable directly, you can see this already kind of hints that there is something wrong with it because it doesn't know local variable outside this function. Right now you're operating outside this function. So if we run this, it is going to give an error. It says name local variable is not defined. You might have also noticed that when we write functions in Python, we are following a kind of pattern. So we are writing the name of the function, putting parentheses and colon, and then there is something called as an indentation. That's very important in Python, and we've talked about it in one of our previous videos at length.